Okay, when you are multiplying, when the two bases are the same, you write the base and you add the exponent. So I call this the mama rule. Call that the mama rule. When you're multiplying, you add the exponents. So here I have x to the third times x to the eighth. And so when you're multiplying, you add the exponents. What does that give you? X to the
11th.
Thank you. X to the 11th. Okay. 2 to the 4th times 2 squared. The base stays the same. The base stays the same. Just like over here, x, x, and it stayed a x. This is going to be a base of 2, and then you add your exponents. 4 plus 2 is 6. Okay. For this one, you need to treat the x's and y's separately. So that would give you x to the what?
5th.
Good, x to the 5th. Then for the y, I'm going to put a 1 right there. So that would be y to the
5th.
Good. And that's your answer. Okay. All right, when you are dividing, you subtract the exponent. So you write the same base and you subtract the exponents. So here we have x to the 5th and x to the 2nd. So we subtract those, and so it gives me x to the
3rd.
Thank you. X to the 3rd. Okay. All right, right here we have 3 to the 5th and 3 cubed. Your base is 3. Your base is 3. It stays a 3. And you subtract your exponents. 5 minus 3 gives you 2. So you can put 3 to the 2nd. What else would you put as your answer?
3 times 3.
What is 3 times 3?
9.
9. So you could also put 9 as your answer. Okay. All right, part C, we're going to treat the x's and y's separately again. What little number can I put with the x right there?
1.
1.
Good. So then you're subtracting 2 minus 1, which gives you 1, and you don't write that. You just write an x. Y to the 5th and y cubed, subtract that, so it gives you y squared. Okay. Any questions? Those of you coming in late, I have recorded this so you can watch it on Canvas, the beginning of it that you missed. All right, 0 exponent rule. Any base raised to the 0 power is equal to 1. The way I remember that, because a lot of people think it's equal to 0, the way I remember that is I remember that I think about that as being an O for 1. O-N-E, 1. So y to the 0 power is 1. Okay. What is 6 to the 0 power?
1.
1. What is 7a cubed b to the negative 1 all to the 0 power?
1.
1. Okay. Anything to the 0 power is 1. Okay. All right, the power rule. All right, so sorry, somebody sent me a chat. I was reading that. So the power rule. So when you're doing a power to a power, you multiply the exponent. Let me close the blind so it's a little easier. All right, so let's look at the differences between this one. Here I have a parentheses in between my exponents. So this means to multiply them, m times n. Up here, I had 2 separate bases. I had x to the n power, x to the n power. I had 2 separate bases. This is the mama rule. That's when you add them. Down here, I only have 1 base. and 2 exponents. That's when I multiply them. So here I multiply them when there's just a parentheses in between. That gives me x to the what?
6.
6.
Good. X to the 6. Okay. All right. The next one, we have 3 squared to the 4th power. Your base stays the same, so it's going to be a 3. And then you multiply your exponents. 2 times 4 is
8.
8. Okay. You could also put 3 to the 8th in your calculator. You're going to get a pretty big number, so I would just leave it like that. All right, this is a z. Somebody who has not answered today, what am I doing with 5 and 2?
Multiplying.
Good. So that gives me z to the 10th as my answer. Okay. All right, here we have xy to the m power, and m goes to both of them. Notice that there's not a plus or minus in there. If there was a plus or minus, you could not distribute the exponent. There's not, just a monomial. Same thing here, the m goes to both of them. So let's do some examples. So here you have a 3 on the outside. It goes to both of them. So it's 2 to the 3rd, a to the 3rd. What is 2 to the 3rd?
Eight.
8. So you get 8, a to the 3rd. Okay. All right. This one, the 4 goes to both of them. What am I doing with the 2 and the 4?
Multiplying them.
Good. So that gives me x to the 8th and y to the 4th. That's my answer. Okay. All right. Going over to this one. The 2 goes to both of them, so it's 6 to the 2nd power. X to the what?
The 6.
Good, because you multiply them. Good, Rachel. All right. What is 6 squared? Anybody?
36.
36.
You could also write your answer as 36, x to the 6. Okay. All right, we've got a lot going on this one. Remember, this 3 goes to everything. So 2 to the 3rd, x to the 3rd, 3 to the 3rd, y to the 6th. Those 2 get multiplied. Okay. All right, you could simplify that a little bit more. 2 cubed is 8. 3 cubed is 27. So you could do an extra step if you wanted to. Okay. All right, negative exponents. Negative exponents means it's going to move. What I always tell my students is if you're in a negative situation, you should move. If you're in a positive situation, you should stay, have some fun. If it's negative, you need to move. You need to get out of there. So we have x to the negative m, which you could put a 1 underneath. So this is in the numerator, and it moves to the denominator. Notice when it moves, it becomes positive. That's the whole point of doing it. If you leave it a negative, you've done work for no purpose. So the whole point of moving it is to make it positive. Here it's in the denominator, and it moves to the numerator. Okay. When you have a negative on the outside of a fraction, you can just flip it. And you could do some extra steps, but essentially you know the x is in the numerator, so it needs to go to the denominator. The y is in the denominator, it needs to go to the numerator, so it flips and it becomes positive. Okay. All right, so x to the negative 3. If you need to visualize it, you can put a 1 underneath. So is x in the numerator or denominator?
Numerator.
To the numerator, so it needs to move to the denominator. So it'd be 1 over x cubed. Notice that it's positive. Okay. All right, 4 to the negative 2. Once again, it's in the numerator, so it needs to move to the denominator, and it becomes positive. You could also write that as 1 over 16. Okay. All right, let's look at this one. This one always throws students off. We only move negative exponents. We only move negative exponents. Is -4 an exponent?
No.
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 Okay. So -4 x to the 5th, all of this, all of that stays the same. The y is what needs to move. And it's in the numerator, so it's going to move to the denominator. So y to the 2nd on the bottom. You only move things with negative exponents. All right, part D, we have a -3 on the outside. Can anybody guess what we do first?
Multiply.
You can. There's actually, I guess there's 2 ways to do it. You can multiply first, or you could go ahead and flip it and make the 3 a positive. But you could have multiplied first, that's fine. Then this gives you y to the 3rd over x to the 6th when you make the 3 go to both of them, okay? All right, part E. We have 2 sets of parentheses. What do I do with the 3 and the -2?
Keep them there.
Flip them.
Say it again.
Flip them. Or the negative exponents.
Well, okay, I see what y'all are saying. Let's go ahead, and again, there's lots of ways to do these. Let's go ahead and do the mama rule first. So I multiply 3 times -2, which gives me -6. What do you do with the exponents on this one?
Add them.
Good. That gives you x to the -1, y to the -2. Okay? All right, I'm still not done. What else do you have to do on this problem?
Now do you flip them?
Yes. So the -6 stays because it's not an exponent, and your x moves to the denominator, and your y moves to the denominator, and they become positive exponents. So your answer is -6 over x, y to the 2nd. All right, on F, there's nothing to multiply, divide, distribute first, so we can go ahead and flip things, move it around. A needs to move to the denominator. B stays because B has a positive exponent. B stays. C moves to the numerator. And D moves to the numerator. Okay, you just move them around. All right, on G, I am going to distribute this -2 first. Again, there's multiple ways to do these. You can and get the same answer as long as you keep working on them till you get it simplified. All right, so this would be -2 to the -2. This would be x to the -4 because you'd multiply those, and y to the +8. All right, I'm not done because now I need to move these two because they have negative exponents. All right, so negative 2 to the negative 2, that moves to the bottom. So it'd be negative 2 to the positive 2. All right, look at this one. This is a very good example. Your exponent becomes positive when you move it. The base does not change. So this negative 2 stays a negative 2, but your exponent becomes positive. We also need to move x to the denominator. So x to the positive 4, and then y stays on top. You could do one more step if you wanted to. You could do negative 2 squared, which means negative 2 times negative 2, which is positive 4. So you could also say y to the 8th over 4x to the 4. You could also submit that as your answer. Okay. This is just going over what I just said. If you have negative x, you don't move it to the bottom because the negative is not with your exponent. Okay, and then same thing here. Negative 3 does not move to the bottom because it's not an exponent, it's a coefficient. So the negative 3 would just stay negative 3, okay? All right, another thing to remember. Negative 3 squared means negative 3 times negative 3, which is positive 9. Here, negative 3 squared would mean negative 9 because there's not parentheses. So you would do 3 squared, which is 9, and then add the negative. So I really should have parentheses right here. And there were parentheses in this problem, so I'm not just making them up. There were parentheses, so I should have written them again. All right. Okay, let's do some more examples. All right, number 1, can I multiply those?
No.
No.
No, why not?
The 3 does not have an exponent.
Good. So you have 3 and 4, which have different bases. So you can't just say that's 3 to the 4th or 4 to the 4th. They have different bases. All right. So you can't simplify that. You could treat them separately if you wanted. So what I'm trying to say is you can't add these exponents because they have different bases. You could simplify it separately if you wanted. You could say, all right, well, this is 3. And then you could say 4 to the 3rd is, I think, 81. Nope, 64. And then you could do 3 times 64 if you wanted, which gives you 192. So you could work it out like that, but you wouldn't add your exponents because they have different bases. Okay. All right, number 2. Number 2. This one is the mama rule. This one is the mama rule. 4 times 2 is 8. And then you would add your exponent, x to the 6. Okay. Abby, can you try number 3?
Would that be x to the 8th?
Very good. X to the 8th. Okay. Addie, can you try number 4?
For x to the 5th.
Very good. Okay. Number 5, Ethan, what you got?
6 to the 8th.
All right. When you are dividing, you subtract the exponent.
Oh, all right. 6 to the 2nd.
Yep. All right. And you could also say that is 36. Either one is fine with me. Okay. All right, Peyton, try number 6. This one's a little tricky, but give it a try.
Would it be 1 over x to the, or x cubed?
Very good. Perfect. So when you are dividing, you subtract your exponents. 4 minus 7 is -3. So she knew it had to move to the denominator. Great job, Peyton. Okay. Tyler, what about number 7?
1.
Very good. That would be 1. Okay. Rachel, number 8.
1.
Good. It would be -1 because all of this becomes 1 and then you have a negative on the outside. So it'd be -1. Okay. All right. Samuel, do you know what I do on number 9?
Would it be y12?
Very good. You multiply those. Very good. Y to the 12th. Okay. Noah, give number 10 a try. Are you there, Noah? Noah, you can send me a private chat too if you need to, but I'm gonna make a note that you're not answering, but send me a private chat if you need to. Ariana, can you help me with number 10?
Yeah, just hold on a second.
Okay.
I already forgot how to do it.
Okay, so the 2 and the 4, are you adding those or multiplying them?
Multiplying.
Yep, that'd be x to the 8th and then y to the 4th. Okay. All right, Lisbeth, can you help me with number 11 or is your computer messing up? She's having computer issues today. All right, Hooper, can you help me with number 11?
Okay. So for 1, I guess the exponents will be subtracted, so it'll become 3. But like to the power of 3 anyway. Then the number should be, yeah, it should be, yeah.
So you divide the 6 and the 2 to get 3, and then you subtract the exponents, okay? All right, EJ, can you help me with 12?
Two x to the 3rd.
Very good. 2x to the 3rd. Okay. Jacob K, 13 has a couple steps, so let's do it one step at a time, Jacob K. Let's do everything to the 2nd power and everything to the 5th power. So what would that give me for my first step, Jacob K?
G to the 8th and C to the 2nd.
Yeah, so 2 to the 2nd. So 2 to the 2nd, C to the 2nd, D to the 8th. And then what do I write for this one?
C to the 5th and D to the 5th.
Good. Okay. Do you know what I do next, Jacob K?
Add C to 2nd and C to the 5th.
Perfect. So that gives you C to the 7th and then D to the 13th for your answer. You could also put a 4. You could say 4, C to the 7th, D to the 13th for that one. All right, Riley, you're up for 14.
Okay,
Let's-
1 second.
Here, just talk it through with me. Let's do the 4 to everything first. So what do I write?
It would be the 2 F4. It would be 2 4
Uh-huh.
F4
Uh-huh.
G16.
Very good.
Is that right?
Very good.
And then it would be F6 G6.
Very good. All right, we can do one more step. Do you know what the last step is, Riley?
To condense it, make it tiny like the last one.
Yep, and so we have to add now because we have 2 separate bases. So we add. That gives me F to the 10th and G to the 22nd for that one. Okay. All right, number 15. Number 15, Larit, you're up for 15.